So, just something about the chain rule, okay? If I have a random derivative like dy dx, okay? If I do y dx like so, what I can do is I can change this into the y something dx over, and it can be any d something I want. It can be ds for both of them. It could be dh for both of them. You just don't know what one you're going to use until you're in the question, okay? So what I'm trying to say is that's known as the chain rule. You're going to use that a lot in rates of change, okay? Now, a spherical snowball melts at the rates at 75 centimeters cubed per hour. It's melting over time. Its volume is changing over time. That makes this dv dt. Volume changing with time. That makes sense? It's dv dt. Now it's going to be a minus. Anybody tell me why? It's decreasing, a minus 20. Find the rate at which the change of the radius is when the radius is r. Now, we want to find out what dv dr is. Oh, sorry, no, excuse me, dr dt. See the word rate? Rate usually means with respect to time. So when you see the word rate, dt is usually on the bottom. We're looking for dr dt. Okay? Now, dr dt, we're going to have to use dv dt. And then, what will that mean over here? Sorry? dr dv. It's basically the upside down version of dv dr, isn't it? Now, you can do it that way if you want. Now, how do you find dr dv? That's the hard part. So, volume of a volume of a sphere is 4 over 3 pi r cubed. Differentiate it. Okay. Turn it upside down. Do you understand that derivatives can be, they're like fractions. If I say 1 over 2 equals 2 over 4, if I turn both sides upside down and say 2 over 1 equals 4 over 2, it's the same thing. So that's all I did there. Substitute it in, so dr dt ends up to be minus 20 over 20 multiplied by 4 pi r squared, so it's going to be dr dt ends up to be minus 5 over pi r squared. What does it say the r value is? R value is 2. So how do you do that? R equals 2, so it's going to be minus 5 over 4 pi. Put that into the calculator, let me know what it is. Do you have a lot?
Yeah,
3.039.
No, 0.39.
Yeah, grand. What's the units? Radius length. How much is your radius shrinking? Radius is normal length. So it's just centimeters per second. If it was volume, it would be centimeters cubed per second. But because its radius is measured as a straight line, basically it's just centimeters per second. Anyway, you see the second part then?
It's not minus.
Oh, it is minus, yeah, because it was minus earlier. Can anybody tell me what is the rate of change of the surface area when the radius is 5 centimeters? Okay, so this is interesting. Surface area. So, let's just rub all this out. Almost start from scratch, if you will. Okay. Whew. What is surface area? 4 pi r squared, straight from your notes. Okay. What's the rate of change? Rate means automatically what? dA dt. That's what we're looking for. Okay. dA dt. When the radius is 5. So, dA dt will be dA dr all over dr dt. I found dr dt earlier, didn't I? It was minus 20 over 4 pi r squared. Remember we got it from the volume in the first question? So the ADR, differentiate that. Anybody?
8 pi r.
8, differentiate that and you get 8 pi r. And dr dt being our minus 20 over 4 pi r squared. Pi r cancel, pi and that one cancels. 8 divided by 4? 2. 2 into minus 20? Oh sorry, 2 multiplied by minus 20? Minus 40. Minus 40 over r. What's our r value for this question? 5. Minus 40 over 5? 8. Now, area is two-dimensional, so two-dimensional units. And then rate per second, minus per second, there you go. People are wondering where I got the ADR from. You differentiate 4 pi r squared to get 8 pi r for the ADR. Cool. Hemisphere question?
Yeah.
Okay. Now, this one's an interesting one, right? So you have a hemispherical bowl. Always helps to, I suppose, draw a quick diagram. Okay, so there, and then there's your hemispherical bowl there. Okay. Now it has a radius of 6, and that's including the way down as well. And it contains water to a depth of h. So you're going to have some water in here, like so, and the depth of the water is going to be h. So you can argue that that's h there from the bottom. Okay. The volume of the water. So volume of the water is a third pi h squared 18 minus h. Water is poured into the bowl at a rate. What does that mean? It's changing volume, right? Volume is changing. Three-dimensional measurement. Are you listening, Frank? Three-dimensional measurement is volume. It's over time. So the VDT equals 4. Find the rate, keyword being rate again, just dt on the bottom automatically, at which the water level is rising. So dh dt, right? H is the depth, and it's rising when the depth is 2. Now, see this hemispherical bowl business? Decoy. Alright? We already have pretty much everything we need here. The whole point is to find out what? Now, look at this, alright? The VDT ends up to be the VDH over multiply by. What's the point of the question? So, the HDT ends up to be the VDT divided by the VDH. Okay, let's find out what we know the VDT already, don't we? The VDT? 4. Now we have to find the VDH. So what's the VDH, guys? Differentiate. What type of rule? We have two options here. We can do the product rule, or we could multiply out and do a simpler version. I'm going to multiply out. Okay? Multiply a third pi h squared by 18, and what do you get? 6 pi h squared, or 18 over 3 pi h squared. Multiply your third h squared by another h, and what do you get? Minus a third pi h cubed. That's V. Now what's the VDH? Sorry? 12 pi h. Multiply 2h by 6 pi. And then this one, minus pi h squared. H equals, anybody? H equals 2. That'll make it 24 pi minus, anybody? Pi h squared? 4 pi, because h is 2. That equals 20 pi. 4 over 20 pi? 1 over 5 pi, which is equal to, anybody? 0.0636. What's the measurement? Height and time? Centimeter per seconds. Okay.